Okay, so this will be the next video in the series, and this one is going to cover the device context. Hopefully, it's going to give you a little bit better understanding what the device context is and how it integrates with your application. Okay, so a device context is a structure maintained internally by Windows. The structure is composed of graphics objects along with the attributes as well as graphics modes. Device context structure, when created by the operating system, is hidden from the program and can only be accessed by function calls such as select objects. So, in other words, you have no direct access to the structure other than through the function calls that the Windows API gives you. Your program has no direct access to the objects or its attributes of the DC structure. Okay, the only way to access and change the objects and its attributes is through the function calls that are provided by Windows API. So let me show you basically how to think of it. It's like this. Think of this as an operating system. Okay, you have a couple objects here on our right hand side. We have pen object, brush object, bitmap object, font objects. Those objects are nothing more than structures themselves. Okay, now those objects are linked, so they're created somewhere in the operating system memory, and they are linked basically to your DC structure, which is also basically a structure through a handle table. So here we have, like, let's say, pen objects that's created at, let's say, memory location 00045343, and then we have a pen handle table that takes that memory location. Okay, the Windows will assign a handle, which is basically, as we said, like a key or an index that links to that memory address, and that handle is then given to your DC structure, where the DC structure has objects as pen, brush, bitmap, font, path, plate, region, and has a couple graphics modes that help your program basically to display the drawing. It gives you more customization how the drawing appears, that have background, drawing, mapping, polygon fill, and stretching. So basically, the objects and the DC structure are basically just structures that are linked with each other through a handle tables. Okay, so you can think of it that way. Yeah, so DC structure here links to a handle table, which in turn has an address of the actual location of the objects that are in the DC structure, but the objects themselves are basically nothing more than structures in themselves. So let's take a look here. Let's start with the basics. Okay, so here's how to think of it. Let's say on the right hand side we have the operating system, and on the left hand side we have the code. So let's say we have here, we call a function called create pen function. We specify the style, which we call solid, so pen style solid. The width of the pen, which is 5 pixels, and the color. We use an RGB macro, which I'm going to go over what it does in a few moments. And we specify the integers for the intensity of the red, green, and blue colors. So in this case, it's going to be a green color. Okay, so when you call this function, you can think of it that way. So when you call this function, the operating system in its memory is going to create a structure with your pen information. So with the width, it's going to be 5 pixels, style, solid, and color green. It's going to save that information at a certain memory address. Let's say in this case it's 04578, let's say. It's going to take that address, copy to the pen handle table, and it's going to assign a handle value to it. Then that handle value that the Windows will assign to that pen that we just created, to that structure, okay, to that memory address of that structure, okay, it's going to be given to you when the function returns. It's going to be given back to you. So that way you can reference that pen that you just created. You can use that handle, which you can think of it as a key, to reference that pen, the information in that structure, the pen structure, so you can use it in the future. So okay, so that's how they are linked. Okay, so you got there. And then what happens when you no longer need it, that object, we have to call what's called delete object. So you have to remove that object from memory. So think of it this way: when you call delete object hpen new, you typecast it to hpen. The system basically will remove that green pen from memory and remove the handle value and memory address from the pen handle table. Like, this may not be 100% accurate, because what the system might do is just keep the handle value but remove the memory address here, so it makes it no longer valid. So I'm not sure how that exactly works, but the way I think of it is just, when you call delete object, it removes the handle value and the memory address from the handle table, and then removes the structure from memory in itself. Okay, so now let's look here. Let's look to the next step. Okay, so let's look at this way here. Okay, here we go. Let's say we have the first step. We want to draw something in our client area. So what we're going to do here first is going to be, we're going to create a pen, a green pen here. So we're creating a green pen. So what it does, just to reiterate, it's going to create a pen in the memory, the operating system. It's going to put the address of that pen, the structure of that pen that we just created, into the pen handle table. It's going to assign a handle value to it. In this case, it's 1, 2, 3, 5, and it's going to return that handle value back to us. Okay. Next, we're going to retrieve a device context for our window, for the client area of our window. So these are called what's called common device context. Okay, you get a basic device structure. Device context structure allows you to draw in the client area of your window. It does not allow you to draw outside the client area of your window. So those are what's called common device context. And those common device contexts are saved in a special memory called cache for quick access. Okay, so that way other applications can use it. But because there are only so many of them available, and they can be used by different programs, once you're done using it, you have to release it. So that way other application can use it, because as you know, Windows is a multitasking system. So different applications can run at the same time and might need access to those handles, to the device context. So therefore, as soon as your application is done using the device context, it should release it. Okay. So those are the common device contexts. So the first thing we're gonna call get DC. Okay. And we're gonna specify for which window we want that device context to be linked to. Okay, so we specify the handle to our window. So at this point, a couple things will happen. A, the system will take the handle to our window. It's gonna look to see which device contexts are available. It's gonna give us one of the 3 device contexts, which in this case, I just put, let's say, the device context with the handle 3214. So that's how they're gonna link together. Then it's gonna look up that device context. It's gonna go there. It's gonna load the default values into the device context. Keep in mind that some of those default values, they vary from window to window. So for example, the H brush, the handle to a brush, is different for each window, because the default brush is basically the brush that we specified in the window class structure. So when we created the window class structure and we specified the brush, that's going to be the default brush for that client area of that window. Okay. And then it's going to load those default values in there. So that way we can use it when we draw something in our client area. So that's how the procedure works. So yeah, so here we have basic pen handle table. It's going to load default pen here for us, right? And then they are linked to the DC handle table. Has a handle to DC that has the address to the DC structure. And then we also have another window, another table that links our window to that DC handle right here. Okay, now we want to draw something in the window. Okay, let's say we want to draw a line here in our window. So here's how it works. So again, so we have the create pen function. So we specify the PS solid 5 pixel width RGB macro, which I'll go over in a few minutes. This will create a structure in the operating system for our pen. So we go here. This is the structures that we'll create here. So width 5 pixels, style solid, color green. This structure here will be linked to the in the pen handle table. The Windows will assign a pen to pen handle here. We'll link it to the address where the structure is located at, and it's going to return that handle back to us. Next step, we're going to get our device context. So we're going to specify for which window we want to draw in. Okay, so we're going to call getDC function. We're going to specify the window of the client area that you want to draw in. The system is going to look up which device contexts are available. It's going to return us the device context. It's going to put basically link our window to the device context in the window DC handle table. It's going to return the DC handle back to us. It's going to go and load the default values into that device context for that window. The default values will be loaded. So at this stage, we have the handle to the device context with our default values for that window. The next step, so that's basically, so like we go here, so we link here the DC context to the window. Here, the handle is being loaded here, and then the information is being loaded there. Now, the next step, we're gonna go and we're gonna change the default pen to our green pen we just created. So we're gonna call select object. We're gonna specify which device context we want to use and what pen we want to load in there. So what happens here when it's HDC, the function is going to go to the DC handle table. It's going to look up the DC handle. It's going to look up based on that. It's going to retrieve the address and it's going to go to the DC structure, to the memory where the DC structure is located. There, it's going to take the handle to the green pen and it's going to copy that handle into the handle value for that handle location for that pen. Okay, so that way the DC structure now will have our updated pen in there ready to go for drawing. So at this point, we're gonna go and try to draw a line. So we're gonna call line to HD. So we're gonna specify the handle and we want to specify where we want to draw it to. We're gonna draw it to X 20 direction and Y 20 direction. So what happens here? We're gonna go to the, again, retrieve our DC. We're gonna go to the DC handle table. We're gonna look up the address where the DC structure is located. We're gonna go there. Once we're there, the function is gonna use basically the handle value for the pen because the lines are drawn using pens. We're gonna retrieve the handle value. It's gonna go into the handle table, pen handle table. Then it's gonna look up the handle value. Based on that, it's gonna retrieve the address of the memory location where the pen structure is located. It's gonna go to the pen structure memory location. It's gonna retrieve the values that the pen needs to use. And based on those values, it's gonna draw our line in the window that we specified here, in the client area of the window that we specified. Okay, so when you specify as the handle to the window, that's how it knows. So the DC is here is linked to our window. Then finally, we need to, when you're done with the drawing, you need to select alt objects. This is very important for the common device context. You have to select the alt objects that you removed back into the device context structure. So you call select object, sorry, with the handle to device context and the alt pen handle. So that way the system will put the alt pen back in. And then what happens? The next step, you have to release the DC. So you specify the handle to the window and the DC handle to the device context. And you think of it when you call it release DC, is gonna basically think of it as deleting from the table the handle to your window and the handle to DC. So this uncoupling basically, so they're uncoupled now. So the DC handle can be used by different applications or different windows. Okay. And then finally you call delete object hpen. You cast it to an hpen and then delete the object that you created. Yeah. So now, okay, so let's look over some of the attributes. Some of the variables that are defined. Just a refresher that you're going to see there, especially when you deal with the graphical device interface in Windows. So HGDI object stands for handle to graphical device interface object. It's a void pointer, basically, of that void pointer. A void pointer, pvoid, is simply a 32-bit value. So it can store a 32-bit value on a 32-bit machine. Handle is defined as pvoid, so it's a 32-bit value. HDC, so handle to device context, is defined as handle. HWint, so handle to window, is defined as handle. Unsigned long is a D word, so it's a 32-bit value. Color reference is a D word. Okay, and color reference has the following format. It's a 32-bit value, but as you notice, the most significant byte here, it's not used. So just the last 3 bytes are used. Okay, the least significant bytes are used. So BB stands for blue intensity of blue color, G stands for green intensity of green color, and R stands for red intensity of the red color. Okay, and you specify the color reference, let's say blue as equals 0 in hex format, right? X 0 0, so the first byte has to be, or the most significant byte has to be 0, and then you specify the intensity, of the colors. Next one is get DC. Okay, so that is a device context handle for the window. You specify the handle to the window. Release DC. You specify the handle to the window and handle to device context to uncouple them, basically. When you call create pen, you specify the style, the width, and the color reference for the color. And when you select objects, so this is one of the functions that you use, to manipulate the device context structure to customize it for your own needs. Okay, so you specify a handle to a graphical device object. Okay, it can be bitmap, brush, font, pen, region. Next thing is type definition. WinBool is an integer, and bool is defined as WinBool. So WinBool and bool basically are integer values. They're not true Boolean values. They're integers. Delete objects takes an handle to graphical device interface object. And then line 2 takes a handle to device context and location X and Y direction where you want to end it. And so the function draws the line from the current location that was saved in handle to device context structure up to but not including the specified point X and Y. Move to EX basically takes a handle X and Y direction where you want to move to and a point structure, so it can return the old point back to you. If you put a null there, it will not return the last coordinate back to you. Okay, so update the current position in the HDC structure to the X and Y coordinates. If long pointer to point is not null, it will return the old position in the point structure. If long pointer to point structure is null, then the current position will not be returned. Now, here's the thing. I put it here that it updates in the HDC structure. Again, this may not be correct, but I like to think of it that way, that when you call move to EX HDC, that somewhere in the HDC structure, that Windows saves the location, where the coordinates where you should be start drawing from. Okay, so that's that's something makes it a little bit easier to understand. Okay, so next thing here. Okay, let's cover this thing here. Okay, so let's cover the RGB macro. So the first thing is byte is defined as unsigned character. DWord is defined as unsigned long, and color reference is defined as DWord. So the RGB macro takes red, green, and blue, but returns blue, green, and red values. So you need to understand that here, when you call RGB, you make sure you specify red, green, and blue. But if you specify color reference directly, make sure you type in 00 and then blue, green, and red. So they do switch position there. Okay, and the way it works is like this. Let's say we call an RGB macro with 10, 10, 10. Okay, so you have 10 for intensity of red, 10 intensity of green, and 10 intensity of blue. And maximum intensity is 0 to 255. Okay, not to exceed 255. So here's what happens. So you have 32-bit value for red, 32-bit value for green, and 32-bit value for blue. So the first thing what the macro does, it says byte R. So we have byte R. I isolated it. It's going to take 1 byte of red, just for red, and it will drop all the other 24 bits. The byte G, this thing here, and with those 2 arrows, 8 means it will take 1 byte of green, and then it will shift 8 bits, so that it will add another 8 bits to the right of it. So that's how its shift goes. The next thing is byte B. It will take 1 byte of blue, and it's going to shift 16 bits to the right. Okay, sorry, to the left. We'll shift 16 bits to the left. So that's way here. And then this here is going to OR it. It's going to combine all those 3 values together. So we're going to get basically like this. And so we're going to end up with blue, green, and red, like here. And finally, we're going to typecast it to a color reference. So the color reference basically, because we already have 24 bytes, I'm sorry, 24 bits, my apologies, 24 bits. We need 32 because color reference is a DWord. So when you cast it to a color reference, the system was going to add another byte in front of it, which is those all zeros that are not used. Okay, so the cast to color reference converts the value to a 32-bit unsigned long value. So that's what the RGB macro does. So the main importance here is to remember when you call RGB macro, make sure you specify 10 red, green, and blue first. If you use color reference, you specify blue, green, and red. So that's the only switch that takes place. Okay, so here's the suggested steps when dealing with the functions, with GDI functions. Here's what the suggested steps you might consider following. So step 1, you create all the objects that you plan to use in your drawing. So in our case, we call create pen with a solid style, 5-pixel white, and an RGB macro to get a green color. Then we obtain our device context. In our case, so we can get DC and do to a window, or you can call begin paint. I will not discuss begin paint in this video. It's going to be discussed. It's going to have a separate video on itself when I do like a VM paint message. I'll go over that, because the begin paint function does more than just returns device context. There's more involved there. Then we select objects that you want to use in the device context. So once we have our device context and we have created our objects, we select those objects to put them into the device context. So we call select objects. H, we specify the handle, the device context, and the object that you want to load. Make sure you save the alt object. Also, you have to, because we're gonna have to reload that old object back to the. You have to put it back in. Step 4, which is optional, you can change the graphics mode options. Okay, this is optional. I will not discuss this in this video. It's going to go in the future video. Step 5, you move to the location you want to wish to start drawing. So you call move to EX function. So you specify the handle to device context where you want to move to. And if you want to the old coordinates to be returned back to you, you specify a point structure here. I mean a pointer to a point structure. Then you draw your graphics. So you call, let's say, line 2. You specify HDC and then draw the line to the location you want, like you specify where you want to draw to the coordinates. Step 7, you put the original object back into the device context. Step 8, you release the device context. So you call release DC. In my case, I think I just use the begin paint, so I also called end paint, which is also releases the device context. And then step 9, delete the object that were created. So you call delete object with the objects that you created, to free up memory for future use. Okay. So that's the steps here. So let's go back here. So let's go over the type of device context that we have available. So for the display device context, we have class. So class device context is not to be used anymore. It's a relic from the 16-bit Windows operating system. It's no longer valid and it shouldn't be used. Okay. The next device context it's called the common one, which I just discussed. Okay, the common device context are used by applications that do not use drawing operations frequently. Those device contexts are stored in special cache of the operating system memory, and each time your application requests common device context handle, the system will load default values for the device context objects and the drawing modes. Unless your application changes the default objects or modes, any drawing done will be done use the default values. Because common device contexts are stored in special cache in the operating system for quick access, there is only a limited number of them available, and as a result, your application should release them as soon as it's done drawing with it. When your application releases the common device context, all data that was loaded into it is lost. So each time your application retrieves common device context, it has to load all the objects and modes that it is planning to use in the drawing operation. So each time you retrieve common device context, you have to basically reload all the objects back into the memory of the device context. Okay. Now the next step is the private device context. The private device context retains the data as long as the window that created the private device context is not destroyed. Private device contexts are not part of the system cache, so releasing them is not necessary, and calling release DC has no effect on them. The system will automatically delete them when the window that created them is destroyed. They are created by specifying class style onDC in the window class structure. Okay, so when you create a window class structure, you type wc.style and you specify cs onDC. They're mainly used in applications that use lots of drawing operations, like when plugging in OpenGL, which I will show you in maybe in the next couple of videos, somehow that we're gonna plug in OpenGL. Okay. Window device context. A window device context allows your application to draw anywhere in the window and not just the client area of the window. The applications that process VM non-client paint and VM non-activate messages usually retrieve the window device context so that they can have custom non-client areas. To retrieve window device context, you call get window DC. Okay, so you use window device context to draw like title bars and so forth. So outside the client area as well. Parent device context. A parent device context is designed to be used with child windows and not with top-level windows or pop-up windows. With a parent device context, what parent device context does is simply sets the child clipping region to that of a parent window so that the child can draw into the parent window. Yeah, so you specify the parent window context by including CS parent DC. So yeah, so I think the parent DC, they used that one to speed up the drawing of the components of the child window components. So I think that's why they use those ones. Then we have the printer, which is safe. Pretty much printer device context is used for printing. You create printer device context by calling create DC. You create DC and you have to delete it when you're done by calling delete DC. Memory device context. The memory device context allows an application to store output in memory rather than send it to the screen or printer immediately. It allows part of the system memory to be treated like a virtual device. An application can load bitmap into a memory first and then copy it to the client area using bit bleed function at a later time when it's needed. So basically, you can load the bitmaps images into memory, and whenever you need them, you just call that bit bleed function. So it's much faster than having to load them each time you need it. So you load it in once, you store it in memory, and whenever you need it, you just copy them to to the printer or you copy them to your device to the display. Okay, so you don't have to load them every time. And then information device context. Information device context main purpose is to pull default information from device such as printer or any peripheral device. So you just if you want to obtain some default information about some device that's plugged into your computer, you can use the information device context. So yeah, so let's look here at the code here for a second. Yeah, so here, let me just start here. Okay, so we're going to use the VM paint function here. Okay, so let's see. Okay, and so we'll go here. That's good. Okay. Okay, so let's look at some code here. So VM paint here. Okay, so let's run this here. Okay, so we're going to look at these items here. Okay, so this here. So is what we have. First, we create pen solid 5 pixel color white, and then H pen green. We create pen solid pixel green pen. We call begin paint, which I'm not going to discuss here the function, but the begin paint function gives us the handle device context. Then we call select objects, and the first thing we can do, we basically specify the handle device context, and we get stock object. We get black brush. So this is one of the brushes that already created by Windows. Okay, by Windows creates a couple stock objects for you that you can use without having to create your own. And then we're calling the rectangle function, specify device context, the starting position, and I think that's the ending position where you want to draw. Okay, so when you go here, so this is the black box here, that's the rectangle that's created. Then we select, doing the same thing, we just select the white brush, we call it here. So that's the next rectangle is white brush here. Then what we're doing here, the next step is set background color here. Okay, we're doing this stuff here. So this set background color, we're specifying as green color, RGB macro. What this does here is basically changes the background color of this here. When we type it out, the background color is green. Okay, so that's the graphics modes. I will discuss that in more detail in next video. Okay, so here you're calling the text out function. We specify HDC, and then we specify location where you want to start. Hello world. We type in that, and then the length of the hello world. Okay, so that's there. The next thing, if we call select objects, we put our new pen in there, which is the white pen, the H pen new, so it was white. We call move to EX, so we're moving to within the client area, we're moving to the new location, which is 20 in the X and 300 in the Y direction. We don't want the alt coordinates back, so we put null there, and we're drawing a line, HDC 5400. Okay, so what it does here, so this white line, that's what it is. So we moved here to the 2300. So from this location, from 0, 0, you move 20 to in the X direction and 300 down in Y direction. Okay. Now, the next thing is we select the green pen and we draw another line from that alt location here, from this location here to there, to specify it. So we're going to 5500. So we're going basically 50 this way and 500 this way. Okay, so 500 down and 50 in the X direction. And then next thing, we specify, we load a DC pen. A DC pen is a special pen. The DC pen allows you to change some of the attributes by calling set DC pen color, specifying the attributes of the DC pen. Not all pens you can change the attributes. In order to change basically you have to create a brand new pen and load it in to modify any color or variables. However, DC pen will allow you to change the attributes without having to create a new pen. So we specify to a blue color, and then we call line to 120 to 520. So this is the blue line here. Okay. And then finally, we call select object, so we put the alt pen back into the DC structure. We call end paint, which basically does a couple things, but one of them is in decouples. So it basically calls the release DC, so decouples window from the device context structure. It also validates, I think, the area. And then delete objects, we delete our objects. Okay, so that's the first video. There's going to be another video. I'm going to go into more detail about how to use these stuff like background drawing, mapping mode, polygon stretching, regions, path, so forth. So how to use those items, that's going to be in the next video I'm hoping to do. Okay, so thank you for now. Okay, take care.